Hey guys, Dr. Brown here, and tonight we have a Calculus 2 problem, which, as I say every time I do a video, this one's a really cool problem. I always say that, but it is, okay? All right, at the end of the videos, I always say, together let's build a better tomorrow, and do that how? Do that through math. That's the purpose of all of these videos, is just to help kids out to be better tomorrow than today. Link up, I would encourage all of you out there, link up with a local school, help the kids, buy them books, supplies, whatever they need, so that they too can be better tomorrow than today. Okay? All right, let's get after it here, guys. This problem, when I first looked at it, I thought, oh, I'll just do the conjugate of that, because I don't have a squared term here. And I thought, well, I can get one by multiplying that by 5 minus 4 cosine theta. Well, the more I chewed that, the bigger it got. So that didn't quite work out. So then I turned toward the trig identities that are out there. Is there anything that would allow me to reconfigure that cosine theta? So let's see here. All right, so you know cosine 2 theta equals cosine squared theta minus sine squared theta. Okay, well that didn't really do anything for me, because I need cosine theta, not cosine 2 theta. So I had the bright idea, I'll just divide that by 2. Divide all my angles by 2. Now I have a cosine theta, and it equals cosine squared theta over 2 minus sine squared theta over 2. I was feeling pretty good about now. Okay, well, I have a form here that's similar to a tangent. So I thought, why not let u equal tangent of what? Theta over 2. So now I have this triangle. I'll put it down here. Theta over 2, and it's what? U over 1. So that means the hypotenuse is 1 squared plus u squared. So I'm feeling good now. Okay, but I need to get cosine theta in terms of u. Well, all right, so cosine theta equals cosine squared of theta over 2. So my angle is theta over 2. And cosine would be 1 over square root 1 plus u squared. And that's squared minus sine squared, so sine is opposite over hypotenuse, so that's u over square root of 1 minus u squared. And again, it's sine squared, so we're squaring that. All right, so when I square those, the radical sign drops off, so I have 1 plus u squared, and I have the same denominator. So it's going to end up 1 minus u squared over 1 plus u squared. We'll get that right here in a moment. All right, so that is cosine theta. Oh, but I can't do just yet. Why? Because I need d theta. Hey, don't fret, we can do that. I can get d theta out of this guy here. Okay, let's take the derivative. Derivative of u is du. Yeah, okay, the derivative of tangent theta over 2. Don't let the theta over 2 scare you. It's an angle, alpha. I mean, you can simplify that if you want. But you have an outside function and an inside function. So in your derivatives, calculus 1, you learn the general, or the chain rule. Taking the derivative of the outside function times the derivative of the inside function. So the derivative of tangent of any angle, tangent, is secant squared. Secant squared, what? Theta over 2. Now that's the outside function. The inside function is 1/2 theta. So if I'm taking the derivative of 1/2 theta, now it's the constant multiple rule. 1/2, I pull that out, times the derivative of theta is d theta. So now I have my d theta. I need to isolate it. So I'm going to multiply by 2. So that would cancel this. Divide by secant squared. Secant squared of theta over 2. And that equals d theta. Whoa, I got to get it in terms of u though, right? So that's 2 du over secant, which is 1 over cosine. So if cosine is 1 over this, secant is this over that. So that's the square root of 1 plus u squared. But it's squared, and that's over 1 squared. So the radical sign drops off. So that's 2 du over 1 plus u squared. And that is d theta. Now then, we can do it now. Okay, let's plug in what we have. What do we have? We have d theta and we have cosine in terms of u. So we have the integral. I'm going to put this over 1 for the moment. I'll put d theta out here. 5 plus 4 cosine theta, which is 1 minus u squared over 1 plus u squared. And all of that times d theta, which is 2 du over 1 plus u squared. Okay, I could FOIL that, or I could just say I've got integral of 2 du over 5 times 1 is 5 plus 5 times u squared is 5u squared. Now then, multiplying this times this part, those cancel. Now it's 4 times 1, which is 4. 4 times a negative u squared is minus 4u squared. So let's collect some terms. I'll pull the 2 to the outside. Du over 5 plus 4 is 9, plus 5u squared minus 4u squared leaves me 1u squared. So 9 is what? 3 squared. It's at this point that your teachers would want you to recognize that if I let a equal 3, I have a squared equals 9, right? Which is what I had, 5 plus 4. Okay, so this integral, forget the 2 for the moment, is 1 over a tangent inverse u over a. So we have a 2, multiply here, a was 3, u is what? Where'd u go? Did I erase it? Oh, here it is. U is tangent theta over 2 and it's over A, and A is 3, plus C. That's what your teacher would want you to remember, that if I have the integral of du over a squared plus u squared, it's 1 over a tangent inverse of u over a. Now, I'm 66 years old. I probably don't remember that. However, I know how to calculate and get that. So let me write that down. That's 2/3 tangent inverse of what? 1/3 tangent theta over 2, or tangent theta over 2 over 3 plus c. That's what we're trying to see how we get that. Alright, I'm going to erase, so take a snapshot. 3, 2, 1. Alright, I'm going to erase some of this. I'm going to leave my u up there. I'm going to get rid of this. Alright, what did we have here? We had 2 times the integral of du over a squared plus u squared. And we said a squared equals 9, a equals 3. I'm going to let u equal a tangent theta. So du equals a secant squared theta d theta. Okay? Now, so I have 2 times du, which is a secant squared theta d theta, divided by u squared. Well, if I square u, I get a squared tangent squared, right? So I have a squared plus a squared tangent squared theta. Okay, let me factor out the a squared in the denominator. So we bring down the secant squared theta d theta divided by a squared times what? 1 plus tangent squared theta. A divided by a squared leaves me a. And what's 1 plus tangent squared? Secant squared. So I have secant squared divided by secant squared. That becomes 1. So now I end up with just 2 over a times the integral of d theta. So that equals 2 over a theta. Now what did we say theta was when we first started, when we went to the theta world, if you will? So we have 2 over a, and u over a is tangent theta, so tangent inverse of u over a is theta. Okay, well, what was u originally? U was tangent of theta over 2. So, what will that go back to? A was 3, so we end up with 2/3 tangent inverse of tangent theta over 2 over a, or multiplied times 1/3 plus c. And that, my friend, would be the integral of d theta over 5 plus 4 cosine theta. And you can see we ended up with the same thing here. So again, this is 2 times the integral of du over a squared plus u squared. You need to recognize that as 1 over a times tangent inverse of u over a. And we had used the u sub of u equals tangent theta over 2. Interesting problem. I'm sure there's other ways to work that. That was the method I chose. Why are we doing this? I said it at the beginning. Together we're trying to build a better tomorrow, and do that how? Do that through math. All right, guys, keep studying, and we'll talk to you next time. Thanks.